Hello, good morning everyone. So I'm David, I'm the founder of Server Density. We help our customers monitor their environments from locations around the world and then get into the infrastructure, into the servers, waking you up in the middle of the night and giving you the data you need to fix problems. So I built the original version of Server Density. I've been programming for about 15 years now, originally in PHP, but more in the last 5 to 8 years in Python. And that's what Server Density is built in. Python, MongoDB, and we have around 150 servers, primarily in the US, but we have monitoring nodes in about 30 different countries around the world. I also did our first deployment of Puppet, which is about three and a half years ago now. And I'm going to talk to you about that transition from where we were with nothing all the way to what we've got now. But as a brief prelude to that, a couple of weeks ago we started a thread on Reddit for sysadmin jokes and had over 350 submissions, and we've produced a notebook with the covers having the top voted jokes on. So if you'd like a free copy of that, then just go to serverdensity.com/knock-knock and you can put your address in and we'll send you a free copy. So the agenda for this talk is to go through the basics of Puppet and why you should be using it, and then look at some objection handling which you may have yourself or colleagues, friends who are against using Puppet or config management generally. And then we'll also look at a few specific use cases why, if you're in a cloud environment, it is particularly useful. And then finally look at some more unusual use cases. We'll be focusing mainly on config management, just because that's what Puppet is good at by default. But there's some use cases that we use it for, like deployments and failover, which I'll talk about briefly. Now, the first question is, why Puppet? But when you're asking that, you actually have to take a step back and ask, why config management? And when you're asking this kind of question, it can be related to the same question of, well, why should you be using source control? The same kind of considerations apply. If you're on your own or you're in a small team, then perhaps you can use Dropbox to share files or not even use anything for source control. But when you actually start thinking about it, the reasons begin to make sense. And the first one of these is the fact that as a developer working on infrastructure, or even as an operations expert working on infrastructure, there are a lot of advantages to having your infrastructure as code. Obviously, you can use source control itself within the code for your infrastructure, and this means not only as a developer can you translate your experience and your development environments from what you're actually building on a day-to-day basis, but you can use that to control and manage your infrastructure. And then you can get all of the benefits of source control, things like versioning, being able to use branches, commit messages, full history of your project, the ability to revert code, and if you're using something like GitHub, you can use issue trackers and perhaps in particular pull requests to do code reviews on your infrastructure. You can also take advantage of consistency. So this is perhaps less useful when you have just a single server, but everyone's ambition is to have probably more than one server for your project. And so when you're dealing with these infrastructure environments at scale, whether it's 2 servers or 200 servers, having consistency across the entire platform is really important. And this means that you understand that all of your servers are the same. This is useful for debugging in particular, because if you can rule out common differences across a fleet of servers, then it allows you to rule out annoying things that you might have to debug around what package versions are deployed, what config file versions are available in which area. And so you can really cut out the really boring parts of debugging and trying to troubleshoot problems just by knowing that your entire environment is exactly the same. Readability is also important, and this goes back to the point of having your infrastructure as code. There are a number of projects you might have been working on over the years, and if you have to come back to something, you don't necessarily remember what is going on, then having the infrastructure defined within code that you can just read through will really speed things up. Not just for yourself, but also for teammates. If you're bringing other people onto your team, whether they're new employees to the company or new members of the team in general, just being able to read through your config management code is a big advantage rather than having to spend a lot of time explaining things, or even worse, having to log on to servers, figure out what packages are installed, what operating systems are being used, and all of the quirks and differences that come up when you might be running different operating systems and different versions of them. And then as your company is growing, you're likely to come across audit requirements. Whether this is because you're in a regulated industry like finance or healthcare, or probably more likely you want to investigate a security issue, then you want to have a log of exactly what has been going on. This can be done by looking at syslog, of course, but it's much nicer if you have a full version history of your infrastructure code, and also when things were deployed and what was going on at the time. You can use that to look back to correlate deploys, for example, or changes to config, so you can then link them into security incidents. Now, config management has a number of particular use cases where it makes sense, and the first of these, and probably the most obvious, is installing packages. So every operating system has its own package management, whether that's RPMs or DEBs, MSIs on Windows, or other operating systems. They all have different ways of doing things and are different across different versions. Now, if you don't use config management, then this problem is something that you've got to solve. Either you've got to know yourself, you've got to have experience with each of the operating systems, or you've got to be able to look up all the details, looking through version histories or the documentation online. And this is really a waste of time. Why are you doing this when there's an API available, an abstracted layer? You can use config management just to say, install this package, and let the config management tool do the heavy lifting of actually installing the repositories, getting the right keys in place, ensuring the packages are signed correctly, installing them into the right location, and complying with the directory structure standards for each operating system. Deploying these across large numbers of servers can also be a massive pain. If you have to log in and execute apt-get install on every single server, or try and write your own scripts to parallelize that across multiple servers, again, it's stuff that is really just a waste of time. You can write a couple of lines of code, deploy the new config management code itself, and then leave the config management tool to get the package installed across all of your servers. And versions are also important here. So it's not just installing the very latest version of a package, it's making sure that you have a specific version. So you might spin up 5 servers and install a particular version of a database, and then a couple of months later you need to install a few more servers behind that. If you don't pin the version that your older database servers are running, then the newer ones will just install the latest package. And this might not be a problem, but if it's a new point release or there's some change in behavior, you're going to get inconsistencies. Now, of course, you can pin packages on the command line, but are you going to remember which servers you pin them on? A lot easier is to define this within your config management code. Specifying a particular version means that it will always be deployed on whatever server that you're setting up, whether it's a new cluster or bringing new servers into an existing cluster. And you can also control the deployment of new code. So instead of having databases upgrade themselves automatically and causing downtime or changes that you weren't expecting, you can do controlled releases. You can test your new applications, the new versions within development environments, and then when you're happy, do the rollout into your production. Perhaps the most annoying thing to deal with is config files. This is in particular when you're upgrading packages and there's a new config option. The package manager wants to overwrite or try and merge your config. Or if you've got different configs for different server types, perhaps a different CPU type needs different config options on the Linux kernel that you might have tweaked. or just generally you want to have different configs across different applications. Either you have to edit the files manually and try and figure out how to maintain them on each individual server, or you put those config files into some kind of source control. But if you're going to do that, then you might as well have the config management system manage it for you anyway. Not only for the config file itself, but also for the location of that file. Each of the different operating systems has its own standard for where config files should go and where packages should go, and that changes sometimes in different releases. Instead of having to remember where all these files should be and the different paths that a database or web server might look and what the order is for where those configs should be, you can let the config management deal with that for you. And you either put the raw config file itself into config management, or in a more flexible way, you can use templates. And these can then read in the variables about your infrastructure, so you can really customize them based on exactly which server, or which cluster, or a series of tags, for example. And then as your infrastructure matures, you're likely to come up against patches, hotfixes, changes that you might need to make in production to improve performance or to fix bugs. And these are all often done on an ad hoc basis. You might fix a couple of servers manually and then forget to do the rest, or you might bring new servers online and they don't have those patches applied. This is another reason why you should be using config management. You can obviously test it in a staging environment first, but then when you're happy with it, you can define it within the config management manifests and have whatever it is you're using deploy that out to all of your servers consistently. So looking at Puppet specifically, now we've kind of built a case about using config management. There's a few features of Puppet that make it a really good choice. So the first of these is Puppet DB, and this is an advanced database that has all of the information that Puppet uses available in a queryable format. So you have an entire database that you can query as you need to get information about any part of your infrastructure. Previously, you could use config variables to define whatever you might need to deploy in config files, but the best practice way of doing this now is using Hiera, which is a key value store. And it's really useful for storing those config values that you might need to change without having to go into files or know the manifests themselves. So for example, you could define a load balancer pool within Hiera, and Puppet will automatically read that out when it's deploying. If you need to change that pool, then you simply make a change within Hiera rather than having to edit config files or go onto the command line. The next tool is Factor. And this is essentially a tool that you can use for analytics. It allows you to query facts about your infrastructure. And this is particularly useful if you want to find particular nodes or to get a report about what might be deployed and what versions. So imagine that you're deploying a security fix for OpenSSL and you want to find the servers that have a particular version deployed. You can use Factor to do this. You can find those servers and then they'll have the patch applied just across those. And this is a lot easier than trying to figure it out yourself by logging onto the command line, especially if you have thousands of nodes that are changing, perhaps in a cloud environment all the time. And looking a little bit further outside Puppet itself, into the community, the Puppet Forge is essentially an open source community for your infrastructure. So no longer do you have to be an expert in every single technology that you deploy. There are a lot of modules out there for pretty much every package that you can reasonably think of, and not just installing it. You've got documentation around the config variables, and more often than not, people have written in code that will allow you to automatically apply performance tweaks and changes based on the best practices for that application. This means you don't have to learn those applications anymore. Obviously, you still need to know the details of how to operate them, but when it gets down into the real detail of performance tweaking and perhaps bug fixes, then you can leave this to the community. There are experts in every single technology, that have committed Puppet Forge modules, and a lot of the commercial companies behind those technologies have done the same thing. So if you want to deploy MongoDB or MySQL or Nginx or Apache, then all these modules are available from official sources. And importantly, they're kept up to date as well. So you can just rely on community to make sure that you are using the latest version and that your config will work. And then finally, if you're willing to pay for Puppet, you can get access to a graphical interface to your infrastructure. And as the default being command line, you might think, well, why would I want an interface for that? Well, it does give you a nicer view of your infrastructure. You can get good reports about what's going on. You can even control things from there, so you can execute commands and install packages. But this is perhaps most useful when you are dealing with incidents or on-call alerts. So instead of having to get an expert sysadmin to come in and help you fix a problem, if there's a known checklist of things that can be done, then perhaps one of your junior ops engineers can just follow a checklist, execute a couple of commands by pressing a few buttons in the Puppet console. And this will save you being woken up as a senior sysadmin, but also help to avoid mistakes. So instead of having someone make a mistake with a command line, you can just press a button in the console. So moving on to a few objections about why I shouldn't use Puppet or any config management generally. And the first of these is that, well, I only have a couple of servers. It's not really worth my time to do this. And in fact, this is what my opinion was when I started Server Density. We didn't think we had time to set up a config management tool. So the first question in response to that is, well, are you planning to grow? Are you planning to add multiple servers? Is this a project that's going to grow into the future? Either it's a hope, or that you know, based on some analysis that you've done, that this is going to be the case. Because if it is, and you're going to be configuring servers manually, then do you really want to be doing that when you get to 10 servers, or 100 servers, or 1,000 servers? At what point are you going to deploy config management? And going back to that consistency I mentioned, having a consistent environment saves your time. So whilst it might take a little bit of extra time to get config management up and running in the beginning, if you want to avoid having to try and debug problems which might just come down to an old config file or an old version of a package, then you can avoid that by using config management. And what kind of environment are you going to be deploying these in? Are they physical bare metal servers, which don't come and go often, or are they more likely cloud servers that are going to come up and down in minutes or might scale very quickly? And to what extent is this a stable environment? Are you going to delete servers to be able to redeploy from fresh and then have to manually install packages? Because if any of these use cases match what you think you might be doing, or you're still experimenting with a project, then putting these things into source control, using Puppet, for example, will really save a lot of time and allow you to keep track of those changes as the project develops. So the next objection is, well, it's too complicated. I don't want to have to spend time learning a new language or figuring out how to write manifests and do things the right way. Well, like anything, this is an initial investment, and it's time well spent because it saves time with things that you might have to change later. Whether that's deploying large numbers of servers that can now be done just by spinning up the new server, or whether it's scaling those in the future. It's this initial investment just the same as it would be if you were using programming libraries. You wouldn't say, well, a programming library for encryption is too complicated, so I'll just write my own. That's a terrible idea. But actually, many of the libraries you won't have to write yourself because of the Puppet Forge. All of these modules, all the packages that you might want to install have probably got modules available. So the bare minimum you need to understand is Puppet itself, and then how to configure Forge modules. The next objection is where I can just SSH in and make the changes myself. Well, you can, but what happens if you need to do that to 300 servers? Are you going to copy and paste the command in every single time? And are you going to make a mistake? How many outages have been caused by someone running a command in a window they thought was in staging, but was actually in production? Using something like Puppet will allow you to avoid those mistakes just because you're not manually doing things. Puppet doesn't suffer from fatigue, it doesn't make mistakes as long as you've written the manifest correctly, and it can avoid problems that just don't need to happen in production. And security can also be an issue here. So you might trust yourself. How good is your public key deployment on your laptop? How secure is that? Do you trust your colleagues? Do you trust everyone in your company who has access to production to make these changes? And it's not just trusting employees, it's just being able to lock down the number of routes into your infrastructure. If you have remote logins open, then you can be vulnerable to zero-day attacks, for example. And auditability comes up again here. Obviously, every command that you execute is written to a history file, but you can easily delete that file. And what is being executed by who may become really important in a security situation where you want to review who's run commands and whether it's actually them or someone who's got access to their environment. And by removing that completely, you can just rely on Puppet. And then the final objection is, well, I can just write a few shell scripts to do this. I don't need Puppet to do that for me. Well, the first response to that is, okay, but what happens when you have 100 servers? You're now going to have to write a way to automate those commands across those servers, or you're going to have to deploy your scripts across those servers. And if you're going to put your scripts into source control, then why not just put them into config management in the first place? You will also have to figure out idempotency, so that if you run your script multiple times, perhaps it fails halfway through, what happens if when you run it again? Is your system going to be in an inconsistent state? And can you safely run your scripts an indefinite number of times and ensure that your infrastructure is only changed once, which is what config management and what Puppet does. And if you're going to use version control for those scripts, as I said, then you might as well use Puppet to do that. And another reason is if your environment is different in any kind of way. So if you're using multiple operating systems or multiple versions of things, then you're going to have to figure out what commands should be run on each operating system and keep those up to date with changes to the operating systems. Puppet abstracts that for you. You just tell it to install a package and it will know what to do on Debian, it'll know what to do on Red Hat Linux, on any other operating system. It's a generic command and Puppet knows what to do. You don't have to code that yourself, you don't have to understand or know what that is, and you don't have to keep it up to date as things change. So a couple of points around cloud environments specifically and why using config management makes sense there. The common design pattern for cloud, not that everyone follows it, is that you should assume failure. Failure on instances, on services, networking, and even availability zones and regions. And so this means you're often going to have to be redeploying things, redeploying servers that have failed, and deploying things to different environments and different availability zones. And if you're having to do this manually, it's going to become a real pain. And really the cloud doesn't make sense if you're having to do things manually. The whole point is to be able to scale very quickly with minimal effort. And cloud environments give you that scalability. So if you're going up to thousands and thousands of instances, then this is another reason why you don't want to be doing things manually. Using config management means that you can get that consistency no matter how many instances you launch. And managing large clusters is a lot more fun when you know that using Puppet you can destroy all of them in just a couple of seconds and bring them back up again with just a couple of commands. And when you do have those large fleets across multiple providers, multiple systems, being able to query those instances and the facts around them is really important. Knowing which servers are where, what hardware they might be deployed on, what packages there are, is a real pain to do. Some of the cloud providers give you APIs for that, but if you're deploying across multiple providers, then you're going to have to figure out how to work with multiple APIs for multiple systems. It's a lot easier to use Puppet's Factor library to do this for you. So now we've talked about config management. I'm going to talk a little bit more about some of the more unusual use cases that the likes of PuppetDB, Factor, and Hiera allow you to do. And the first of these is deploys. So at Server Density, we deploy 10 to 15 times a day, and all of our developers can deploy. And the process is that a developer will work in a branch, and they will then commit that into GitHub, open a pull request, and once it's reviewed and it's gone through our staging environment, it gets built and then deployed into production. So the commit comes in, and our BuildBot server will run through all the tests, and after a few minutes, depending on the build, it will give you a green light that you can then deploy that. We've written a few custom modules and used the Puppet APIs so that we can query our servers and we can see exactly which version, which git commit version of a particular service is deployed. Puppet knows this, and we just query Puppet. And we've built a simple front end that allows us to automatically list all of the servers that are available and have been deployed. And we choose those servers, click a button, and it runs mcollective and tells Puppet to deploy a particular git commit and the build artifacts from that. This is kind of a novel use case, and there are systems like Amstrano products, software service products that you can pay for to do this. We built this before many of those were stable or available, but it didn't take very long for us to build. All we had to do was create a simple web front end that queried Puppet directly, and then make sure we were running the right commands. And now any of our developers can have builds created from branches. They can be deployed onto production or onto staging, and it allows us to speed up development. Another use case is documentation, and everybody hates writing documentation, so if you can find a way to avoid doing that, then it's a good thing. Now, by the very fact that you're writing all of your infrastructure into code, this becomes documentation, because instead of having to know or specifically write down what versions of a database are deployed, where they're deployed, what operating systems you might have available, then someone can just simply read the Puppet manifests, and they can use Factor and log into the Puppet Enterprise console. This saves a lot of time writing unnecessary documentation that then has to be kept up to date, particularly as things are changing in the environment. And obviously there's still things that need to be written down that can't be gleaned from Puppet, but a large majority of the boring things can just be assumed that they're documented correctly just because they're deployed using Puppet. And dealing with failover is also another novel use case, in particular using Hiera to make changes to load balancer pools or which servers might be available within a particular cluster. Instead of having to manually edit config files or go in on a command line, you can just make a change in Hiera or in the Puppet interface, and that change is then deployed automatically across all of your servers. And in most failover situations, it's at a really inconvenient time, probably early in the morning or at the weekend, and so you're probably not going to be in the best condition to make sure that you're doing things perfectly. And so every way that you can find to automate something or to remove the ability to make mistakes is going to be a bonus. And so these are all achieved using the features of Puppet. We're able to query PuppetDB for our deploys. We're able to use Factor for incident management and for keeping the team up to date, not just the existing team, but also new members of a team. And we're able to use Hiera for dealing with failover and configuration. And so that's why I think everybody should be using Puppet. Thank you very much. Happy to answer any questions.
And with the mic, if you could just repeat the question back.
No questions? Not even about the deploy system? Well, I'm happy to answer any via email or obviously around after this as well. So thanks again. Oh, yeah.
So server density is an open source as well, or is it a commercial product?
So the question is whether server density is open source or commercial. It's both. Our agent is open source, and all of our plugins are open source, but it's a software provided as a service, so that part is commercial and closed source.
Thank you.
Excellent.
Okay. Thanks, everyone.